what I do is I'm a transportation engineer. What I do specifically is I design roadways. I design how many lanes there are in a roadway, where the traffic lights are, where the intersections are, and how close they are to the houses in a subdivision. What I had to do is I had to figure out the elevations of certain points in a field, and I had to figure out the locations of certain buildings, roadways, and other things like catch basins and manholes. Now, I had to use trigonometry because sometimes I can't get all the way around a building, for example. I can only get a couple of points. So I can get two lengths, for example, and an angle. I have to use trigonometry to figure out what the third length is. Now, you need to use SOH-CAH-TOA because when you're given the elevations of 2 points and you're given the horizontal distance between 2 points, you need to calculate what the angle is. You need cosine law and sine law because all you're given is the hypotenuse and you're given an opposite, but you need to figure out what the adjacent is. Now, this is really important when you're calculating how deep a pipeline needs to go under the road or how deep the building needs to go into the ground. Okay, well, this is an example of a design of a little subdivision that I've completed. Over here, these are where the houses will go. Here's where all the trees will go, and here's where the roadway goes. Now, under the roadway, we have pipes that bring water to the houses and bring the waste that come from the toilets and the sinks away from the house. When we're calculating the length of the pipes, we need to know how long it is going to be along the roadway. But since the pipes need to be on an angle because the water needs to flow within the pipes, we also need to calculate the length of the actual pipe. Now, using SOH-CAH-TOA, the length along the roadway becomes the opposite length, and the length of the pipe actually becomes the hypotenuse. The angle, if we're off by 1 degree, the pipe here on this diagram might be sticking out of the ground because this line shows where the top of the ground is, or the pipe would actually be going downwards. So if too much water goes into it, this entire area will flood. So the angle needs to be accurate within at least half a degree to ensure that the water will actually flow in the correct direction. Computers are really good. They will speed up efficiency. This drawing, all these calculations done on a computer can take just under 4 hours. If all these calculations are done by hand, it can take at least a week. However, if the computer misinterprets a number, or if a number is inputted incorrectly into a computer, then this won't work. You'll have a lot of flooding, the water will not flow, and you'll have to spend at least a week or two figuring out where the error is. Good rule of thumb to use is make sure that you double check at least 10% of the numbers or the calculations that you let the computer use for you. The most challenging part about being an engineer is meeting deadlines and staying within budget. You're not always given an ideal situation to design things. You're not always given an ideal situation where you can just install a road. There's other things that are always in the way which you need to account for. For example, there might be a building right in the middle of where you want to put a road. So you need to do calculations and figure out what direction you can put the road in. Having written response questions on exams are very important because it allows the students to be able to be creative in their answers. They're not restricted within the 4 selections that are given on a question. They're allowed to apply their own creativity. It not only shows that students have the ability to read a book and regurgitate the knowledge that they've acquired from the book, they're able to think about and process how the information is important, and their interpretation of the information they read, make sure they're understanding the concept and being able to put their own imagination or twist to the answer. The main objective of being an engineer, the main focus of being an engineer, is being able to problem solve and being able to think creatively. You need to be a creative thinker, and you need to be able to find out-of-the-box solutions. You need to see things that the general public will not necessarily see.